Welcome everybody to the talk. So I think the actual title was What's New in PostgresQL for Buster, and that's actually what I'm also going to talk about, but I also want to talk a bit in general about Postgres and Debian. So I'm from Germany, I'm from Creative. We are mostly a German-based services company. The founder, Michael Banck, is a Debian developer, and he's also I believe one or the first European Postgres committers back in the 90s. So Debian and Postgres are the main two pillars of our company, but we're basically supporting everything. Still, a lot of our business is based on Postgres. So we're also doing a lot of work in the Postgres packaging thing for Debian. If you look at these statistics, you can see that in the early days it was Martin Pitt, who used to be at Canonical. I'm not sure where he's working. I think he's working at Red Hat these days. But then around 2010, my colleague Christoph Berg took over, and he basically did 90% of all the packaging work. He packages the Postgres server. He couldn't be here, but he's a long-term, or he's the main Postgres developer, I would say. Adrian is also a colleague of mine. He had 55 uploads, mostly 2016, 2017. So last year, this year, he has been working on other things. And myself, I'm at 51 uploads now, so I'm the second most uploader in the last 2 years, the green. Well, not very easily visible, but trust me on it. So basically, since 2010, 90% of the packaging work has been done by Creative. So also the Creative supports that work as an open source contribution during company time. So as an overview for PostgreSQL, for those who might not know, let's say it's an extensible object relational database system, and it was created as a research project. So that's somewhat important in the sense that it wasn't as, let's say, MariaDB or MySQL, who were really created to solve the problem of web projects basically working well. Postgres was more of a research project, so there's a different attitude also in the way to go ahead. It's vendor neutral, also in difference to MySQL, and but there's commercial support available from a lot of companies, including Creative. It's run, let's say, by the Postgres Global Development Group, but that's not even something like SPI. It's just a thing on paper. It's the group of developers running it. It's not even a legal entity in that sense. But there's a core team of 5 members who make the important decisions. There's a release team, which is kind of important. I will get to that in a second. And there's around 20 committers. I wanted to update that, but I didn't get around it. There's like 25 maybe now. They added a few over the last years. So this also means I have to say that I gave a similar talk 2 years ago in Montreal about what's new in Stretch. So I updated a couple of the slides for what's new in Buster 2 years later. And then this one I forgot to upload in the end. So important for Postgres as an upstream project is there's no copyright assignments, it's not open core, there's no dual licensing, it's straight BSD MIT style, which means that there's many forks and quite a few of them also proprietary, and that's totally fine with the Postgres developers. There's a couple of shallow spoons, let's say, a couple of companies doing some kind of open core-ish thing on top of Postgres, some kind of enterprise ready, even though you have to say that the vanilla Postgres is very much enterprise ready from the get-go. But they add some, let's say, Oracle compatibility features that are not in Postgres because they're too much of a hack or something like that. The release cycle is pretty straightforward these days. It's yearly, and there's a 5-year support by the community. So you get security and bug fixing for 5 years by the security. So this is working very well. Now these days there's a quarterly patch release cycle, so you can actually set a date for, I believe it's the third Thursday of the last month of a quarter, and that's when they're gonna update. They're gonna release the patch release, unless something major comes up in between, which happened like twice in the last 3 years. But otherwise, the patch releases are there, and those are, I believe, whitelisted by the Debian stable release manager. So we're just uploading them straight to stable, so you get these fixes directly from upstream. The Postgres developers from Debian are not backporting specific fixes, but it's getting updated directly into Debian, and you get all the bug fixes there in stable. Also, maybe important, Postgres moved to a major minor, from a major minor to a major release versioning. So it used to be 9.3, 9.4, 9.5, 9.6, but then they skipped to 10, and now they're just having 11, 12. That makes it much easier because they couldn't figure out the real difference between a major and a minor version in that case. But you still have the patch releases like 10.1, 10.2, 10.3, which are out every 3 months. And actually the release cycle, okay, one thing I want to also emphasize is that the release engineering is very similar to Postgres in the sense that they have kind of like a time-based major freeze or feature freeze, and that's usually in spring after the beta, so they have several commit fests, what they call it, where patches are being applied and reviewed, and after the last one, which is usually in February till mid-March, they issue a beta 1, and that means that there is only bug fixes from then on. And then there's going to be bug fixing. So right now we're in the bug fixing phase for version 12. And it's supposed to be released. There's a couple of betas. Usually it's going to be released in autumn, in let's say September. And Stefano had this tweet a couple of days ago where he said also that the Debian now has a very predictable 2-year release cycle. And there's only like a standard deviation of less than 2 months. And it takes around 2 years. So basically what we have these days is Debian releases in about April, and that means you get the, at that point, current Postgres stable release because it's just done before feature freeze in Debian. So you have a Postgres release in September, this is getting included, and then Debian freezes, and then you get the latest version. So that's actually 11 for Buster, it was 9.6 for Stretch, it was 9.6 for Jesse, 9.4 for Jesse, and then maybe there was a bit of a difference back there, but this is very reliable, always 2 major releases, and so let's assume that Bullseye will, if we stay with a 2-year release cycle, I assume Bullseye will release with Postgres 13 by then, which is not yet even, well, which just started development actually. So they branched off the 12 release thing a couple of weeks ago. So that's just to explain how Postgres releases work together with Debian releases. And I just want to give some short overview of the main features of Postgres for those who are interested maybe in databases but don't know Postgres all that well. It's considered to be pretty rock solid in the sense that the developers have a solid first, speed second attitude to developing features, and also maybe a let's develop features in a sense that they can be extended later, but let's have a consistent and working core first and then extend the features in the next couple of releases, which I'll also get into in a bit when I explain the new features. It has a pretty good and consistent coverage of the SQL standard. Useful, also many modern useful SQL extensions. If you're an SQL developer, there's window functions, there's common table expressions, all these nice things you can use for advanced SQL if you need them. And it has a cost-based query planner together with transaction isolation, allows for pretty good concurrent usage of clients. And also query planning, so you can assume that Postgres tries to pick the best plan for your query, even if it's a very complicated query. There's a large number of extensions and associated projects. I'll get to that in a bit. Maybe important to DBAs is that you can have transactional changes to the database structure, so you can start a transaction, drop a table, roll back the transaction, and the table is still there, which is not the case for some other database projects, even proprietary ones. It has drivers for many, so programming languages, there's many different procedural languages, so you can program in PHP, in Python, in Perl, and you can also program server functions in PHP, in Python, in Perl, if you want Java. And there's the general PGSQL procedural language for SQL type server programming. The other thing that has been really gained a lot of traction in the last couple of years are foreign data wrappers. So there's federation between Postgres and other database or non-database systems. So you can federate a Postgres with another Postgres and have transparent access to foreign data sources. So you just run a select query on some table in your Postgres database, but it actually connects to a remote DB2 or Oracle or Postgres database, runs the query there, and returns your query. And it does that in a way that it minimizes the data transfer between the two things. So that allows for very nice interoperability or federation to other data sources. And finally, it's packaged in Debian. So it has been for quite a while, and I'll get into how Debian packaged this in a bit, but I'll first get to the main features that have been added since Stretch. So Stretch ran 9.6, as I mentioned, and Buster runs 11. So first up, the changes in 10 that have been happening since Stretch. So the three big major changes in 10 are logical replication, native partitioning, and improved parallel query, let's say. So logical replication, so Debian, Postgres had so-called physical or streaming replication for about 10 years now. But the problem with that is that you have to replicate the whole instance. You cannot just replicate some tables. And you cannot replicate from one version to another. So this is not useful for major version upgrades, for example. It's only useful for high availability or backup purposes. And logical replication allows you to replicate to a different version of the database, maybe also a different operating system of the database. It allows you to replicate only a subset of your table, so you can maybe replicate several databases into one data warehouse and aggregate them over there. And that works pretty well. It doesn't work so well for high availability in the sense that it's not multi-master replication in the sense that, yes, you can write on both ends, but there is no conflict resolution, there is no replication of DDL right now, like create table statements. You have to really run on both sides and make sure that it works. And also sequences are not replicated right now. So this is just a building block for possible multi-master replication in the future, but it works for some workloads pretty well. But it's not useful to just replicate the whole cluster for a long time. You can use it for major version upgrades. If you replicate it quickly, then switch over, and that's fine, so you don't run a DDL in between. But it's not useful as a general purpose replication system. For this, I would still recommend the physical replication. So improved parallel query. 9.6 already had some parallel query, but in 10 and 11 it just got better, so a lot more queries can now be parallelized. For example, in 10 you can also now parallelize index scans. You could only parallelize full table scans in 9.6. Native declarative partitioning means that now you can partition a table into several subtables. So if your table is very huge and there was some operational problems with getting it dumped or running some administration things on it, you can now split it up into chunks, and it's much easier to handle those chunks. The one in 10 is pretty minimal, but I'll get to the improvements in 11 in a second. There's also client-based connection failover, which means that you can tell, if you have a replicated setup, you can now tell your client, well, those are all my Postgres IPs, possible ones, and please always connect to the primary. So if there is a failover in your cluster, the client will just reconnect to the new master. You don't have to set up the client you don't have to change the IP address for the client or something, even if you don't use a virtual IP or something like that. There's some smaller changes I don't want to get into too much. You can now have a quorum commit for synchronous standbys. That's pretty specialized, but in general, a replication got much easier. And probably important these days, so Postgres hashed the passwords in the server with MD5 so far, and now from 10 on you have the so-called scram SHA-256 mechanism for hashing passwords and authenticating, and that's much more secure. Also, hash indexes got ready. They were broken for a long time, and some multi-column statistics. That's very specialized, I would say. So going on to 11, there has been a lot of changes in partitioning for 11. So now I would say in 11 it's actually pretty useful. So before, for example, you couldn't have a default partition. If you inserted the value and you didn't have a partition for that, it just errored out. Now you can just put all the overflow, let's say, into a default partition. In general, there were performance improvements. It's easier now to handle queries on that. You can also, so in 10 you always only had list partitioning. and you can also now do hash partitioning. And the main, also one of the major drawbacks of 10 was that you couldn't update a row from one partition to the other. That would also error out if you do. You had to really delete it and create it on a new partition. That was very cumbersome. But now in 11, you can just update a row, and it will automatically get moved into the right partition. So that makes it much more useful. Also in 10, you had to create an index on all the subpartitions yourself if you wanted to create an index on a partition table. In 11 now, you can just run a create index on the main parent table, and it will automatically create an index. And I guess partition wine joins is part of the performance improvements. Right, other changes are, again, improved parallel query. You can also now, what Postgres now also parallelizes index creation, so those are much faster in theory. They added a just-in-time compilation of expressions using LLVM. This will be on by default in 12. It can potentially make long-running expressions much quicker than before. There is SQL procedures now. What's interesting, maybe for some database administrators, before, if you added a column with a default, it would rewrite the whole table. That might take a long time if you have a really large table. Now in 11, this will be fast. So this is one of the things that it was contributed by I think it was Salesforce, actually. Somebody from Salesforce contributed this, and it was added by a Postgres developer. So they probably needed it. This makes it much faster for adding columns to your tables. There's covering indexes. There's base backup checksum validation, which means that whenever you run a base backup, this is one of the physical replication backup procedures, the data checksums will actually be validated on the fly because we do the I/O anyway. This is a feature that I contributed. So finally, this will be in Buster. But I also want to talk about, because I said version 12 is already right now in the beta phase, so it's being the bug fixing phase. So a couple of the upcoming features for version 12, which will be out later this year. There will be more partitioning performance improvements. You also get foreign key support for partition tables, which wasn't there before. In general, there's a lot of indexing performance improvements. So the transaction log has been decreased, and the size of indexes has been decreased, so that's better. And a long-standing, this took a long time to come, you can also now re-index concurrently, which means before, if you wanted to re-index an index, it would lock the table for the duration, which can mean that you have a downtime that actually the application cannot use it anymore. But now, this can be done concurrently. It takes a bit longer, but you can still use the index during the time. So this is a nice improvement. Another feature that I contributed was offline activation or deactivation of data checksums. I'll get to that into a second later on. Copy, which is the bulk loading interface of Postgres, now allows for where conditions, so you only copy out a subset of the data. Before you had to copy the whole table, which this makes it much more useful for some use cases. You can now run JSON path queries per SQL JSON specification if you have JSON data. So Postgres supports JSON pretty natively as a data type, so you have a kind of a hybrid relational NoSQL thing. You can run both in Postgres. And there's pretty good support for JSON, also indexing, and this got better with JSON path queries. And there's now a pluggable storage API. It's not being used, but the idea is to allow for other types of storage than the regular storage to be added to Postgres. There are some pain points. I mean, Postgres has been developed in the 70s and the 80s, so time goes on. So there are some pain points with the current storage engine, and they're now working on external storage engines, a bit like MySQL. And so they added at least the pluggable storage API for now, and this will be extended in the future. The recovery configuration got merged, and there are some improvements to COM table expressions. So those are the features in Postgres. Is there any questions maybe so far before I get on to the next? Anything I missed or anything unclear? I can get into more details later on if you're interested. Okay. So I wanted to make this into a word cloud, but I didn't manage in the end. But there's been like 40 new external packages in Debian between stretch and buster. And just want to like highlight a couple. I will not get through all of them because this like I have like three pages of this. But there's a few interesting ones. I will talk about Patroni later on. I will talk about PG checksums later on. There's a couple things. This is a colleague of mine wrote a ClaimAV-based virus scanner extension if you need to run virus scanning. There's now an auditing extension, which is part of, for example, a company managed to get the American Department of Defense to get Postgres approved for their internal projects, and they use the PG audit extension as part of their security infrastructure. So that's a pretty nice one. There's the PG logical extension, which works from 9.4 on, and it's very similar to the internal logical replication. I want to highlight, for example, it's now possible to have external indexes. So PostgreSQL RUM is a new type of index. So for some reason, the Russian developers decided to have all their indexing based on alcohol. So there's a gin index, there's a rum index, and they used to have a vodka index, but I think they renamed it to the rum index. So this is a new type of Postgres index that you can actually have as an extension. So Postgres has a very good extension thing. You can extend it in a lot of ways, and since 11, I believe, you can also now extend Postgres so that you add an additional index type via an extension. It doesn't have to be built in core. The Prometheus SQL exporter is something that we use for exporting metrics to Prometheus from Postgres instance. This is a logical decoding output called wal to JSON. Wal is the transaction log of Postgres transaction log, which allows you to transform the Postgres transaction log into JSON output, so you can consume it for something else. Glom is a long-standing GNOME-based database designer, which is finally in Debian. There is a new resource agent called Path for Postgres automatic failover. So the pacemaker resource agent that was used for general Postgres high availability has some issues, so somebody rewrote this, and this is called Path. So this is a new and improved resource agent for pacemaker, and this helps with logical DDL replication. I mentioned that this is not working by default. And there's some more things in new or being worked on. So OmniDB is a new web-based database management tool, which also works for a couple of other databases. So if you need a nice web-based tool, check it out. There's also pgadmin 4, which is a rewrite of the standard Postgres web administration tool, and it's actually now web-based. But you can also run it on your local desktop. It's kind of, I think it's a Flask application, and this is being worked on, but I think it's still not in you. But this is being worked on, and I just want to mention this because I packaged it a while ago. It's a virtual IP manager for Patroni. I'll get to this in a second. So lots of new projects. Next up, I want to talk a bit about actually Postgres works in Debian, because maybe it's not exactly clear to everybody how this is actually being done. So what Debian does, it packages one Postgres release per version. So as I said, 9.6 was in stretch, 11 is buster. But first of all, there's several Postgres releases, right? So we still support stretch. There's the LTS thing for Jesse. And of course, there's major versions of Postgres. Postgres releases every year. So right now, there's always 5 major versions supported by the Postgres team. And they have incompatible disk format, so you cannot just upgrade like this. So what Debian came up with a long time ago, and I think this was Martin Pitt mostly, to make Postgres packages co-installable. So you have one Postgres package per major version. And there's a wrapper or a framework called postgresql-common that takes care of creating or deleting database instances and putting them in the right, correct location. And then you have each version of Postgres, in theory, work like listening on a different port. So you can run several Postgres servers on the same machine. Each get a different port, starting from the default port is 5432. And this works pretty well, but still you have the problem that Buster has 11, Stretch has 9.6, Jesse had 9.4. So what if you need an older version of Postgres because your application is only working with this one, or you haven't really tested a new one, or you want to test a new version, or you're actually running Ubuntu and not Debian, or you want to upgrade Debian, but you don't want to really upgrade Postgres, right? So you're running 9.6 and you're not sure that 11 works, so you want to upgrade from Stretch to Buster, but you don't want Debian to upgrade immediately to 11. And this is something that has been worked on upstream by the Postgres project, but in this case it's actually the same person. So Christoph Berg both maintains Postgres for Debian, but he also maintains Debian for Postgres. And this is the app postgresql-org project, which is an app repository run by the Postgres project, which has all the packages for all the supported versions by upstream and all the versions supported by Debian and Ubuntu. So it's a bit like backports, except it's an offering for people who are running stable to get it from there. So right now, they're supporting 7 versions of Postgres. Like 13 is the development version, 12 is in beta, as I said. There's 8 Debian and Ubuntu releases. Those are right now supported, and we have 3 architectures. PowerPC 64. There's no ARM support yet. I believe it's basically lacking hardware to build the packages. So you can see that every package has 168 targets. So it's a huge thing. It's run on a Jenkins instance with Jenkins Debian glue, and it's hosted at PGDG built by GGI, which is another company, and it's running auto package tests for continuous integration. So right now there is about like 30,000 Debian packages in it. This is probably when some, like I guess Wheezy or whatever got dropped, and it's just increasing all the time. So 2017 we were at around like 17,000 packages 2 years ago when I gave the talk. Now we're at around 30,000, and there's about, this is on the other side, we have around 250 source packages and around 1,300 dev names, I guess. So just to see that from 2013 when it started, it really went up, and it builds a lot of packages. And those are not the ones that ever got built. Those are the ones actually right now in the apt repository. So there's always some getting purged. So some more information about the Postgres package layout. Or is there any questions about app? I mean, I really want to emphasize that this is a great service, and you can install any version of Postgres that's supported for any version of Debian or Ubuntu that's supported, and including all the extensions. That's why we have these 30,000 packages, right? So an extension needs to be rebuilt for every Postgres version. It needs to be rebuilt for every Ubuntu version, and that's how you get all these packages. Okay. So as I said, the Postgres package layout allows for multiple major versions to be co-installed, and that's basically you have a version and a cluster name to identify them. So the server package would be PostgreSQL 9.6 or PostgreSQL 11. The client package is that. And then all the database directories where the actual data is, they're in Wallet Postgres, and then the version name, and then the cluster name or the instance name. The log files are here. The configuration files are in etc PostgreSQL. There's postgresql-conf. There's some other PostgreSQL files, and there's also some Debian-specific ones. This is the basic server package layout, and Postgres is running, or it's adding a couple of it's adding a couple of additional tools to this. There's a PG wrapper which wraps several Postgres commands, so you can run the PG cluster environment variable to some version number to run that exact version. So you have to just export the PG cluster, and it always will get the right version for you. If you have several installed, or this wrapper also adds another command line variable cluster, so you can actually do this. You can have a PostgreSQL-RC to have this. Then there's the pgconf tool, which I want to emphasize for easy reading and editing of configuration files. And there's a couple of PG cluster things like create cluster, drop cluster to help for instance administration. You can also configure it here, whether you want to have it started directly, whether you want to move your data directory somewhere or the transaction directory somewhere, or do some other things. Maybe I got through this a bit quickly, but I wanted to use the remaining time to highlight a few other helpful projects that we've been working on at Creative. So is there any questions? Because I would now skip subject to how this works. I can just, I will upload the slides so you can have a look, but this is a very nice infrastructure for you to work with Postgres that Debian provides on top of vanilla Postgres. Okay, so I want to get into some other projects that we've been working on. I already mentioned that I worked on checksumming quite a bit in the last time. I worked on the Patroni packaging quite a bit. And we also worked on something called Elephant Chat, which is a Postgres appliance. And we're now also working on a REST API for Postgres instances, which I try to get into if I have the time. So just quickly, PG checksum. So I think it's important that while Postgres is pretty crash safe and it doesn't eat your data if you like pull the plug, there can still be problems with the underlying storage. So there was a problem with the Linux kernel a while ago that if you had some thin provisioning done and the underlying storage would run out of space and you get an I/O error, then Postgres assumed that if you just sync the storage again and the sync is successful, then actually the data is there. But no, it turned out Linux threw away the data. So you can get into some data corruption things every now and then. So this one got fixed, but there might be other ones. So since 9.4, Postgres allowed for so-called data checksums. That is, it stores a checksum of the data in the page header for every so-called page. But it was not so much useful because actually, first of all, it was not used by default, and it's still not on by default. So you have to explicitly enable it at instance creation time. And at least in 11, there was something called PG verified checksums. It's a tool to go through your cluster and check whether all the checksums are actually working. However, the downside of this tool is and was that you need the instance to be offline, which is not something that you usually would do in a production system, right? I mean, you don't shut down the instance and then check the checksums for 45 minutes if it's multi-terabyte database, and then turn it on again. So this is a problem. And then in 12, it got renamed to PG checksums because me and another person added offline deactivation. So now what you can do, you can shut down your Postgres in a maintenance thing, you can activate the checksums after the fact and go up again, and then you have checksums. So you don't need to really remember it at instance creation time. And what we then did is we kind of forked this PG verified checksums or PG checksums on GitHub, and we added a couple of new features, and most importantly, I think, is online verification of checksums. So this didn't make it into 12. There were some reservations by the developers, but this allows to check the checksums online at a production database, which is much more useful than offline checking. And also, we added compatibility with all supported Postgres versions, and not just 12. So you can also download PG checksums for 9.4, 9.5, 9.6 if you run older services. And it's a Debian package, so you can just install it from app.postgresql.org for your version that you're running. And there's some progress reporting and I/O throttling. That's not so important, but yes?
In the beginning, you said you had to activate checksums at cluster creation time, right? So I assume that from that point onwards, every write the checksum would be calculated and would be added to the block or whatever. Then later, it can be activated offline. So you take the cluster down, activate it, bring it back up immediately.
Well, not immediately.
That
means, yeah, right. So it means in practice that you have to go through the whole thing and write the checksum into every block. So that might take some time. So I'm talking about a maintenance window.
So even in the 12 version, it's done the moment you activate it offline. It's a sync job basically. It will calculate the checksum of all your data, and only then can you bring it back up.
Yes.
Okay. And your fork does that in the background?
No, my fork does the verification. So the story is that in 11 there was actually a patch committed doing online activation, but it was revoked because there were some serious reservations about the transaction isolation. So there might be some old backends still having old checksums. So it was not deemed secure enough. So they dropped it for 11, and unfortunately for 12 it also didn't get merged. There is now work again. So in the end, we will probably have online activation of checksums directly in the server with 13, I hope. But as a stopgap measure, at least for 12, then we said, okay, let's at least do offline, because that's much easier, right? You just shut it down and write the checksum in every block. You have to put it up. So that maybe takes like 20 minutes for like a half a terabyte thing, depending on how fast your storage is. But if you have the possibility to have a maintenance window, this is much better than not having checksums at all. Or there's a lot of old installations which got repeatedly upgraded, and even before maybe checksums were a thing.
And you said your fork does online verification of checksums. So without that, so the checksums are not verified during the normal workload.
No,
a command
okay.
that you issue.
I should also clarify that. So they're checksum. First of all, they're verified during base backup, which I mentioned earlier, since 11, and they're also verified when you actually read the data. So yes, they're verified then, but you might have like a large database and a lot of data you're not touching.
It takes a while to get read, yes.
Right, you're not touching like the old data, and it gets corrupted, and then there's a lot of, if it's really a large database, it's not common to actually dump the data. So if you do a dump, then everything gets read, right. But if you're doing a base backup, then also it gets read. But if you did an old base backup, or you're not doing the backup at all, then it might take days or weeks until you realize, and then your old backups are gone again. So this is why it's useful to check periodically. It's also, you can also do a dump to do the check if you want.
So this reminds me of the ZFS scrub, something that you do every now and then to just be sure that checksums are correct.
I guess if you're on ZFS, this is a bit moot because it has its own checksums, but on XFS or something, this can be really a problem. Okay. So the other one I want to get into is Patroni. So Patroni is a thing by Zalando, company from Berlin. And it allows for really easy setup of high availability by Postgres. So it configures and bootstraps a Postgres instance, and it does replication. And what it does, it uses usually etcd, or you can also use one of those fancy cloud-native things to have a key value store of keeping, with a Raft algorithm, deciding which one should be the primary, and also making so that the primary has to update the key all the time in this so-called distributed configuration store. And if it doesn't update it, then there's going to be a new leader election, so it avoids split brain scenarios. So this is a good way to set up a high availability in Postgres these days. It also allows for a REST API for monitoring and administration, so you can use HA proxy, for example, to hook into this. And there's a Patroni control end-user program which uses this REST API to do switchovers or configuration changes. And also, there's this VIP manager package that I talked about by another company that I packaged, which allows to manage a virtual IP on the primary interface, a primary instance, also based on the etcd data. So it checks etcd, am I the primary? It sets the virtual IP address. It checks etcd, I'm no longer the primary. It deconfigures the virtual IP. So you can also have a virtual IP. This is I can recommend this these days for high availability. The problem with Patroni was that it was kind of like a container-based thing, and it didn't really interact a lot with Debian. It would use its own things. It would use its own configuration. You wouldn't have like PGLS clusters, wouldn't show it on a Debian system. So I worked a lot on in the Buster release cycle to get Patroni integrated into Debian, and actually in Buster now I can say that it's working pretty well. So we have a pg create config Patroni utility that you can use to create a Patroni configuration, and then you can start it in the same way that you would start. So I skipped over this, but you can start your PostgreSQL instances via a systemd like this. So you can just start it like this. It will, we started on all the instances, of course, and then it will automatically configure a primary, and the others will do replication, and then you have high availability. And all the things are in the places where you would expect. I have to say configuration interaction is a bit hairy, but it kind of works, and I will integrate it with VIP Manager as soon as that hits the archive. It's still in new for a while now. And also I created an Ansible playbook as a proof of concept where you can have a 3-node Debian Patroni cluster with via Ansible deployed. It's pretty easy, and it works pretty well, I have to say. So the last 5 minutes, I just want to get 2 more things that we were working on, which might be interesting if you're running Postgres. The first is so-called Elephant Chat. It's a thing, open source, that we created at Creative, allowing for an integrated web-based administration of Postgres instances. So basically, we're bundling all the proven components that Postgres ecosystem has, which we believe are the best. So Grafana for monitoring, Prometheus for monitoring. So we have this SQL exporter. We use Prometheus, and then we have a Grafana dashboards. We use pgbadger for log file analysis and pgbackrest for backups. And then Cockpit for system administration, and Shell in the Box if you want to shell into it. You can, of course, also use SSH. And the underlying thing is implemented via postgresql-common and systemd glue, let's say. And it looks like this. We are going to change the front end probably for the next major version, but right now it works like this. You have all the Debian clusters on your system here where you can check the logs or do a backup or see whether it's working or whether they're down. And then you have buttons to all the other things. So I just want to show the Grafana dashboards that we set up. So you get some overview and you get some other things. There's a lot of metrics working there, and it's automatically, if you pg create cluster a new instance, it will all get hooked up to the administrative interface. You get a new Grafana dashboard, you get new backups and stuff like that. And we're also working now, and this is still technology or like a working preview, on a REST API to manage Postgres instances. So either a local or remote Postgres instance, which it's a Python-based thing. It's also on GitHub. So you can maybe get or patch things. You can change the configuration of a Debian Postgres instance, or you can restart an instance. I assume you can also create an instance. And we will integrate this with Elephant Chat to actually have then remote, so you can remotely administrate all your Postgres instances. So this will take some time, but then I think this is a very nice solution to manage Postgres on Debian. So that's the things I wanted to talk about. There's some more links over here. Is there any quick questions?
So what's the difference between using the VIP manager and a QuadroSync pacemaker related resource to manage?
Sorry, what was the
benefits?
first? What's the first one? I didn't.
The VIP manager you mentioned. So to move on the virtual IP.
Well, yeah, sure. You can also. Well, the thing is, with Patroni, you don't have to set up pacemaker, right? So before you would have pacemaker and QuadroSync, and then yeah, the VIP would be part of that setup. But this is kind of cumbersome. You have to really test it, and there's some. It's not easy. And Patroni makes this much more easy. And you don't need to use VIP manager. You can either do the VIP. Yeah, you can manage it with, if you have that set up, do it like this. You can use client-based failover. You can use HA proxy to query which one is the primary and then just route traffic. It's just a nice, easy way to get a VIP working, which integrates well with etcd.
I was thinking on Stoneth and all others, if they are needed or not.
So Stoneth, that's a good point. I mean, what Patroni does is there's this time to live thing, and you can integrate it with a watchdog, with a hardware watchdog. And basically, if the Patroni instance fails to update its leader key, it will then just like shut down itself. This is kind of like the integrated Stoneth thing. Of course, if you are like 100% want to make sure, maybe pacemaker is still the best thing to do this kind of stuff if you have Stoneth working there correctly. But I believe this works reasonably well, and Zalando uses it at that scale, I would say. A couple other people use it at scale, so be a bit wary, but it should be a pretty good solution overall, I would say.
Is PG Bouncer still a thing?
What was the question?
PG Bouncer,
yes?
Is that still a thing?
It's still a thing, yes. Some people use it also with Patroni. There's some, so for example, right now Scram authentication doesn't work with PG Bouncer. It's being used. Certainly there's some big companies using it a lot. There's also a thing called, So there's a Russian company who created a new bouncer multi-thread. So one thing that PG Bouncer doesn't do is multi-threading. So if you have a lot of transactions, there might be a problem, or a lot of connections. So they did a thing. I can give you the name after the talk. I can't remember it right now. But in general, there's PG Pool and PG Bouncer. And PG Bouncer is a lightweight solution for this, which still works, yes. But it's not really a HA thing, right? So it's a connection pooler, connection router, but it doesn't provide high availability in itself. It's just one building block, maybe. So I think we're running out of time. I mean, I skipped over the development part. If anybody's interested in developing Postgres, like packaging Postgres extensions for Debian, come talk to me. I can explain how we're doing it. I just want to give a talk more useful to the end user. But if you're interested in how the packaging works, I'm happy to talk about that in a BOF or in person later on. So thanks for attending. Thank you.
Thank you.